Welcome back to my channel, guys. So this is question 2.64, and it says that interest centers around the life of an electronic component. Suppose it is known that the probability that the component survives for more than 6,000 hours is 0.42. Similarly, suppose also that probability that the component survives no longer than 4,000 hours is 0.04. So these are the two conditions provided here. So on the basis of these conditions, we have two parts of this question, which is part A. What is the probability that the life of the component is less than or equal to 6,000 hours? Okay. And B is what is the probability that the life is greater than 4,000 hours? So before proceeding to the solution of this question, let me write the given data here. So the given data here is that the probability of survival for more than 6,000 hours is 0.42. So survival is greater than 6,000 hours, or 6k is what? That is 0.42. Similarly, suppose also that the probability that the component survives no longer than 4,000 hours is 0.04. So the probability of survival less than what? Less than 4,000 hours. Okay, so no longer than for the 4,000 hours is less than or equal to 4,000 hours. That is what? 0.04. Okay, so these are the two conditions which are given here in this question. On the basis of these questions, what do we have to do? We have to find the solutions. So what do we have to find out here? Let me write it here. So I have to find out the probability that the life of a component is no less than or equal to 6,000 hours. So I have to find out the survival is less than or equal to 6,000 hours. I have to find out this one. And similarly, I have to find out in part B what? This is part A. And in part B what? What is the probability that the life is greater than 4,000 hours? So survival is greater than 4,000. I have to find it out. So now in order to solve the questions, what I have to do, this is the solution. I have to solve it. And in part A, I usually know that the overall probability of the component survival and its failure is basically equal to 1. That is basically the fundamental rule of the probability. So similarly, if you want to find out the probability of the event X, so the probability of X prime is what? That should be equal to 1, where X prime is equal to 1 minus. Similarly, as portraying the same fundamental concept here, what we can do here is that for part A, for the probability of survival less than or equal to 6,000 hours plus the probability of the survival greater than 6,000 hours, this must be equal to 1. Okay, so this is basically the fundamental concept which I have to apply here, and putting values here because I know the value of this here as well. So let me write their values. So what will I get? I will get here probability of the survival less than or equal to 6,000 R plus this 0.42 should be here. So 0.42, that should be equal to 1, or subtracting both sides with the 0.42, what I will get? I will get here survival is less than or equal to 6k. So here I will get 1 minus 0.42, and this will be what? This will be 0.58. Okay, so that is basically the answer of part A which we had here, and on the basis of this formula I have found out the probability of the event, and that is also on the basis of this equation A. Similarly, now proceeding towards the part B, here again, now again employing the equation A, what I will get here? I know here that the probability of the survival less than or equal to 4k plus the probability of the survival greater than 4k, this must be equal to 1. Okay, so now putting their values, I know that here in the given data I know the value of this variable. Okay, so now putting it here, I will get 0.04 plus the probability of survival greater than 4k, so that is 1, or subtracting both sides with the 0.04, what I will get, the probability of the survival greater than 4k, this should be 1 minus 0.04, and here I will get what, it will be 0.9. Okay. So this is what, this is the answer of part B, which I have found out on the basis of this equation. Okay, so we have seen here that the implication of this standard and fundamental concept of the probability has been applied here, and on the basis of this we have found out the solution of our question. So that's it for today. If you have any question, you can ask me in the comment box. Thank you so much. Welcome back, guys. I hope all of you will be fine. So this is question 3.40, and the statement of this question is: a fast food restaurant operates both as a drive-through facility and a walk-in facility. On a randomly selected day, let X and Y respectively be the proportions of the time that the drive-through and walk-in facilities are in use. Okay, so here in the given data, let me first write the variables which represent the certain quantity, and here we can see that this X is representing what, this is representing the drive through facility. Okay, so X is the drive through facility and capital Y is what, that is the walk-in facility. Okay, so now after representing them and denoting them with certain variables, let me see that what is it. So, and suppose that the joint distribution function of these random variables is given by f of xy, which is 2 by 3 x plus 2y for all the x's which are greater or equal to 0 and less than or equal to 1, and similarly for y which is greater or equal to 0 and less than equal to 1 and 0 elsewhere. Okay, so on the basis of all these given data, we have to determine part A, B and C. Okay, and in part A we have to find the marginal density of X. Okay, so let me solve it, and solving it, this is the solution, and in solving it we have to find the marginal density of X, and if it is f of xy, so let me represent this with G, and let me have it here G of X. Okay, so now in order to find it out, we have to integrate this given function within the ranges of the given values, and also integrate it with respect to the other variable in which we are not interested to. Okay, so here we have to determine the marginal density of X, so we have to integrate it with respect to another variable which is Y. Okay, so let me write it here, and the ranges of, let me have here 0 1, because both the variables has the ranges of 0 to 1, and let me write the function here, and that is 2 by 3 x plus 2y. Okay, and integrating it with respect to y, because it is here x, and so I have to integrate it with respect to y. Okay, so let me solve it, and this 2 by 3 is a constant value, so let me put it outside this integral, and integrating all these again, what I will get, integrating this x with respect to dy, what I will get here, I will have, this will be a constant for it, so I will have here x, y, and from the range 0 to 1. Okay, similarly here, seeing this one, what I will get here, this will be 2, while this will become y square divided by 2, 2 and 2 will cancel out, and here we will get y square, so it will also be from the range 0 to 1. Okay, so let me solve it, and here solving it, what I will get here, this will be from 0 to 1. So here I will get x because it will be 1 minus 0. Okay. Similarly, here we can see that this is y square and that is 0 to 1. So here I will get 1. So therefore, the answer of the marginal density for x is given here, and that is the solution of part A of my question. Okay, so that is the solution. Now solving part B of my question, find the marginal density of y. Again, all the things will remain the same, just I have to integrate this function with respect to what, with respect to x, because I have to find it with respect to y. Okay, so here the variable or marginal density, let me represent it with h, and the variable here I am going to use is y because I want to find the marginal density of y. Okay, now using the same integration from 0 to 1, this is for the values of x. Okay, here we had those ranges for the values of y. Okay, so now writing the function, the same function here, x plus 2y, and here it will be d of x. Okay, so now we will get what, let me move this 2 by 3 outside of it, and here it will become what, integrating it with respect to x from 0 to 1, what I will get here, here we will get x square divided by 2 from 0 to 1, because now I have been integrating it with respect to x. Okay, similarly here this will become 2y. Okay, 2y, but here we can see that we have to integrate it with respect to x, and there we have only 1, and these 2y will be represented as a constant here. So therefore, integrating it from 0 to 1, I will get here x, and it will be from 0 to 1. Okay, so now let me solve it. This will be 2 by 3, and here x square by 2, it will become what, it will become x square divided by 2, so it will become 1 by 2. Okay, similarly here looking at it, I will get 2y. Okay, or multiplying this 2 inside of it, what I will get here, it will be 1 plus 4y. Okay, and that is what, that is the solution of part B of our question. So we have found out the marginal densities for x. Okay, this is A, and for marginal densities of part B, which is the marginal density of y. Okay, so now we have found out these marginal densities. Now let us proceed towards part C of this question, and we have to find the probability that the drive-through facility is busy less than 1/2 of the time. Okay, so this is part C, and I have to find out the probability that the drive-through facility is busy less than 1/2 of the time. So let me see that which variable represents the drive-through facility, and that is x. Okay, so I have to use this function which is x, so I have to see that that is less than 1/2, and that would be calculated by using the function which is given here, and it will be from 0 to 1 by 2, which are less than 1 by 2, because this is a continuous function. Therefore, I have been using this 1 by 2 as well, and here I have to use this gx dx. Okay, so now putting values here, and the values here are given here. So here I will get 0 to 1 by 2, 2 by 3 x plus 1 dx. Okay, so now here it will become 2 by 3, and integrating it, this x will become x square divided by 2 from the range 0 to 1 by 2, and here it will become x from 0 to 1 by 2. Okay, so ultimately I will get here what, this 2 by 3, and here 1 by 2, this x square will become what, is will be 1 by 2 whole square minus 0, so it will become 1 by 4. Okay, also this will become what, this will become 1 by 2. Okay, so let me multiply this 2 inside, so I will get 1 by 3, and here 1 by 4 plus 1. Okay, so let me solve it further, and here I will get, this will be 1 by 3, and here this will become 4, and this will be what? This will be 4, 4, and this will be 5. Okay, so ultimately I will get what? I will get 5 divided by 12, and that is what? That is the solution for part C of my question, which has been given here. Okay, so that's it for today, in which we have basically solve a real world problem in which a given joint density function of two variables has been given, and on the basis of it we have found out some parts of it. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. So this is question 4.11 and 4.12. Today we are going to talk about them as the two questions are closely relevant. So therefore, let me first talk about question 4.11 and then 4.12, and both of them are related to the mathematical expectation of the continuous random variables. Okay, so let us first talk about question 4.11, and the density function of coded measurements of the pitch diameter of threads of a fitting is fx equal to 4 by pi 1 by x square for the x ranges from 0 to 1 and 0 elsewhere, and we have to find the expected value of x. Okay, so in solving it, we have previously seen the formula for the mathematical expectation. As we can see that this is a continuous random variable, so that's why the formula for it would be the expected value of x would be what? We have to integrate it. Okay, integrating it by multiplying the value of the ranges with the value of the density function, and then we will get the output. Okay, so that is the formula we will be using. Here you can see that instead of using the discrete operator, we have been using here the continuous operator, and that is the integration. Okay, so let me first put values here, and putting values here we can very easily see here that the values here would be x multiplied by f of x, which is 4 divided by pi 1 plus x square. Okay, d of x, and the ranges of it are from 0 to 1. Okay, so this is the equation we have. Now let me first remove the constant values from the inside and put them outside. So it will be 4 by pi, and here we will have x divided by 1 plus x square, and it would be 0 to 1 dx. Okay, or we can also write it like 2 by pi, and here we will have 0 to 1 2x divided by 1 plus x square dx. Okay, why did I write it like this one? Because I have known the formula for the integration, that if we have a fractional function in such a way that in the numerator we have the derivative of the function which is in the denominator. Okay, and that is here. So in finding out its integration, we can find out the natural log of f of x. Okay, so here we will get this one. So now using the same formula, we can see here that this is 1 plus x square, and its derivative is here, which is 2x. So therefore we can employ this one here as well. So it will become 2 pi, and natural log of what? The function here is 1 plus x square. Okay, and the limits here are 0 to 1. Okay, so let me put values here, and putting these limits here, what I will get here, it will become natural log of 1 plus 1, and this would be natural log of 2 minus natural log of 1 plus 0 is 1. Okay, so we will get this one. This is what we have. From here we can very easily see that here natural log of 1 is basically 0. Okay, so therefore we will get here, here we will get 2 natural log of 2 divided by pi, and similarly this 2, this can be the power of this 2 as well, so it will be 2 square divided by pi, which is ultimately natural log of 4 divided by pi, and that is the solution of question 4.11. Okay, so that is the solution of 4.11, in which we have employed the use of this formula for the continuous mathematical expectations. Okay, so I hope you have understood all the steps which I have carried out. Okay, so let me remove it. Now question 4.12, if a dealer's profit in units of $5,000 on a new automobile can be looked upon as a random variable x having the density function which is given here. Okay, so find the average profit per automobile. Okay, so in units we know the formula, so therefore what do we have to do? We have to find the expected value of this random variable and then we have to multiply per unit profit over it. Okay, so let me find the expected value of this random variable, and it would be what, employing the same formula here and employing it, what I will get, putting the limits which are 0 to 1 x and then the value of the function which is what, which is 2 1 minus x. Okay, and then dx. This is what we have. Let me multiply these terms inside. So what will I get here? It will become 0 1 and here we will get 2x 1 minus x dx. Okay, or 0 1 multiplying this one inside of it, I will get 2x minus 2x square. Okay, and this would be d of x. Okay, so now integrating all these terms here, what I will get here, I will get 0 1 2x dx minus 0 to 1 2x square d of x. Okay, so now here we will get 2 multiplied by x square divided by 2 from the limit 0 to 1 and minus 2 x cube divided by 3 from 0 to 1. Okay, so let me move down somehow. Okay, so these two will cancel out and from here I will get 1. Similarly here it will be 2 by 3, so 2 by 3 and x cube, putting values here I will get this one, and from it very easily we can see that the answer will be 1 by 3. Okay, so this is what, this is the average value of the automobiles. Now we knew from the statement that the unit profit is $5,000. So therefore, in order to find the average profit, what do we have to do? We have to find average profit here. To find the average profit, I have to multiply this 5,000 with 1 by 3. Okay, so it will become 1667.67 somehow, and that is what, this is in USD and this is the solution of our problem. Okay, so that is what, that is the solution of our problem, in which we have first found out the expected value and then multiplying it with the unit profit we have got our answer. Okay, so that is what, that is the solution of two relevant problems that which are related to the mathematical expectations of the continuous function. If you have any question, you can ask me in the comment box. See you soon.